Calculate the number of subsets and the number of proper subsets for the given set. Okay. So in order to find the number of subsets, we have the formula that tells us that the number of subsets is equal to 2 to the n, where n is the cardinality of the set. It's the cardinal number of the set. So how many elements are in the set? So for this particular case here, I have 1, 2, 3, I've got 4 elements in the set. So the number of subsets is going to be 2 to the 4. So again, 2 times 2 is 4, times 2 is 8, times 2 is 16. So I get 16 subsets. Now the number of proper subsets is going to be one less than this, because it's all the subsets except for the one that equals the original set. So I'm going to have 15, the number of proper subsets. And again, the formula would just be 2 to the n, minus 1. I would focus on just knowing this one here. The number of subsets will be 2 to the n. And then to find the number of proper subsets, you subtract 1. Find the cardinal number of the indicated set. Use the cardinal number formula. Here we go. So the cardinal number formula, this can be expanded for more sets, but it basically says that the number of elements in A union B is equal to the number of elements in A plus the number of elements in B minus the number of elements in their intersection. So for this example here, I have number of elements in A or B is going to be equal to the number of elements in A, we're told is 5, plus the number of elements in B, which is 11, minus those in the intersection, which is 3. So I get 16 minus 3, so there are 13 elements in the union. If you want to know why this works, if you just think about a quick Venn diagram, here's A and here's B. So when I count up the number of elements in A, I'm counting up all these. Then I count up the number of elements in B, I'm counting all of these. And notice that, this part right here in the middle, is counted twice. That's why I have to subtract it. So I count up all the things in A, all the things in B, and then subtract the intersection, so I counted it twice. Use the given cardinalities to determine the number of elements in a specific region. Okay. So for this one here, like I said, we've got 8 regions. I've got 3 sets overlapping, and I need to fill them in. And it starts off by giving me the number of elements in the universe. So that's everything listed here has to total 158. But I have no idea how those are broken up. So like I said, you really need to, when you can, start at the intersection, start in the middle, and work your way out. So the first thing I'm going to do is look to see if I know what's in the intersection of all 3 sets. And I do. I am given that the number of elements in A intersect B intersect C is 11. So 11 is going to go right in here. Okay, next I'm going to, like I said, I'm going to work my way out. So if I look at this piece right here, that's where A and B intersect. So A and B intersect, that's going to give me 21 total. Now I've already counted up 11 of them. So 21 minus 11 is going to give me 10. So the other 10 are going to go right here. If I look at these 2 sets, this is where B and C intersect. I'm told that has a total 20. Again, I've already got 11 here. So 20 minus 11 are 9. Have to go in that other region. So now the 2 of them together will give us 20. Okay, I've got another region. Let's go this one right here. And again, these 2 together have to total 24 because the number of elements in A intersect C is 24. I have 11 already accounted for, so that means 24 minus 11, so 13 will go right in here. And I'm going to keep working my way out. So, now I'm able to go ahead and say, well, how about, inside the set A? I know how many are inside the set A. It has a total 52, but I've already got these 3 accounted for. So, like I said, I'm going to have to have 52 minus the 10, 11, and 13. And so we get 52 minus, let's see, that's 34. And so that'll give me 18. So 18 will go right here. Now I was asked to find how many were in region 3. So I'm actually going to come down here to region 3. So region 3 is this one right here. So I want to look inside the set B. So B is supposed to have a total of 72. So all of B is equal to 72. So 72 minus these other 3 regions. So minus the 10, 11, and 9. And so 72, that's going to be minus 30. So I get 42. So 42 are in region 3. So the other thing I'd like to make note of is remember there's a difference between region 3, which is only in B. So region 3 is in B only. So no overlap with another set. So no overlap with other sets. Okay. So if I want to know what's in B, well then that's going to be, so B is going to consist of region 2, region 3, region 5, and region 6. Everything inside of B. But region 3 is in B, but not in A or C. Okay, I'm going to go ahead and finish this problem out. I've only got 2 more regions I need to find. So let's go ahead and use the fact that C has 51 elements. So all of C has to total 51. And so I already have, you know, the 13, the 11, and the 9. So minus the 13, the 11, and the 9. So I have to take 51, let's see, minus 33, which will give me 18. And so 18 must go right in here. So that is for region 7. And then the last region I have is the region 8. And again, where we started with is we said, hey, notice that I have 158 all together. So for region 8, and this is going to be my universal set, you know, it's inside the universal set, but it's not inside A or B or C. So there are 158 in the universe minus everything that's in A, B, or C. So minus the other 7 regions. So I've got, let's see, 18 plus 10 plus 42 plus 13 plus 11 plus 9 plus 18. That's the other 7 regions. So I have 158 minus, that comes up to 121. And so on here on the inside my universal set, outside of A, B, and C, I'm going to have 37. So there are 37 elements in region 8. Okay, usually this skill is required for answering survey questions. Once you've filled in the regions, then you can answer questions like how many liked only 1 or 2 or 3.